Hi guys, we're going to go ahead and do the Chapter 11 Simulations Assignment 2. So this was more practice where you did not know which type of simulation, if it was one of the ones where you just looked at a set number of items, or if you were going until you found a certain outcome. All right, so here on this first problem here where we were looking at the cereal boxes, we were estimating that probability. So we were going to get a percent. So we're going to look at the 5 boxes. So every trial was look at 5 boxes, look at 5 boxes, look at 5 boxes. And then our response would be yes or no, you got, as to if you got the complete set of pictures. All right. So in this case, we could let each one-digit number, and we could use one-digit numbers because our probabilities were just in the tens, 20%, 30%, 50%. So let each one-digit number represent a prize in the box of cereal, or you could have even just said a cereal box. Let the numbers 1 and 2 be Tiger Woods, 3, 4, 5, Lance Armstrong, and then the rest were Serena Williams, so that was 6 through 9 and 0. Use the random number table, start at the top left corner. So in this case now, a trial consists of looking at 5 cereal boxes, looking at 5 cereal boxes, looking at 5 cereal boxes. So a trial consists of picking 5 cereal boxes. Now, what do you ignore? So think about digits and repeats. So all the digits were okay. Repeats, because each cereal box is independent of the other cereal boxes, then the repeats are okay because each one just represents a new cereal box. All right, your response then, after you look at those 5 cereal boxes, for example, down here, I was doing my set of 5 cereal boxes, and I put an L, S, or a T above each digit to represent who the picture was that we got in that cereal box. And so I did that. So I looked at 5 cereal boxes, looked at 5 cereal boxes, looked at 5 cereal boxes. So when I did 5 cereal boxes, 3 out of those 5, which was a 60% chance, gave me a complete set. So that response was yes or no to if I got that complete set of pictures. So according to my simulation, I expect to get a complete set of pictures about 60% of the time. Now, I think you had also been asked to do 10 trials, and just FYI, when I did 10 trials, I got 70%. Okay, because I expect the law of large numbers. As we do more and more trials, then we're going to get closer to that true probability. Okay, all right, next. I've got the same scenario with the same cereal boxes. However, it says, how many cereal boxes do you expect to look at? So how many do you expect? That expected number is the mean. So that's how many on average. So this is a situation where we don't just look at 5 boxes, look at 5 boxes, look at 5 boxes. We're going to go until we get a Tiger Woods in this case. So each one-digit number is representing the cereal box with the same values for the particular pictures. Now, here's where it's different. Use a random number table, start at the top left corner. A trial consists of opening cereal boxes until you get the Tiger Woods. Again, the repeats are okay because the cereal boxes are independent. So now, and then this is different also, that response is not yes or no, I got a complete set or whatever. It is the number I had to go to get that Tiger Woods. So in this case, when I did 5 trials, I would go until I basically got a 1 or a 2. So I got a 2 there, so that's 3 cereal boxes I had to look at. Then I got immediately, my first cereal box was the number 2. That means I just had to look at 1 cereal box to get the Tiger Woods, and so on. But this time I had to look at 10 boxes to get the Tiger Woods. All right. So FYI, the statistic for my 5 trials was 4. Okay, so it did come out to be a whole number. Just FYI, when I had done 10 trials, I had gotten 4.3. So I guess I wrote this up here. According to my simulation, I expect to have to open about 4 cereal boxes on average to be sure of getting the Tiger Woods picture. All right, and see here in this case, technically this problem could have been done because we were just looking how many do you expect to go until you get one of those items. So this technically could be, again, that geometric probability until you get one. And so that 1 over p was 1 over 0.2, which is 5. And so it's interesting to note that our 10 trials was getting closer to the 5 than just our 5 trials. Okay, because we know, according to the law of large numbers, that as you do many trials, many trials, the cumulative probability, it will settle down to that true probability, the law of large numbers, you see. So it's going to continue to get closer to that 5. All right, number 3, the probability of correct answer choice, because you studied this time, was 80% per problem. So what's the probability you're going to get all of those 6 multiple choice questions? So it is asking what's the probability. We're looking at 6, looking at 6, looking at 6. So there's our 1-digit numbers because it was 80% chance. I did 1 through 8 is correct, 9 and 0 were wrong. Here is where, like the problem we had in our notes, a trial consisted of 6 multiple choice questions. And again, the repeats are okay because each multiple choice question is independent of the other. But our response is yes or no, did you get them all correct? So this time, we still got 0% chance of getting them all correct. So interesting. So when I did just 5 trials, 0 out of 5 of them had 0, so 0% correct. Now, when I did 10 trials, I had gotten 10% correct. I was just curious, so I went and I think I had done 20 trials. 20 trials yielded 30% correct. So that was interesting because theoretically, in the long run, here's what we would have expected, that it was 80% chance with getting all 6 of them correct. So theoretically, 26.2. So again, 5 trials wasn't close at all to theoretically what should happen. 10 trials was closer, and 20 trials was the closest still. See, so again, the more and more trials you complete, the closer you will get to what theoretically should be happening. All right, so here's this number 6, and I had put a little hint video in the notes or in the Canvas page for this to help you. The key is that the rate for the first driving test is different than the rate for the subsequent tests. So I'm going to be using these 2-digit numbers because, we need to be accurate to the ones place, but this is where it was kind of a different situation. So let's take a look at this. So the first time I take that test, I've got to look at the first one as 0, 1 to 34 is a pass rate, and then the remainder are fails. But all of the other times you take that driving test, it's a different rate. 0, 1 to 72 is a pass rate with the rest of them as failures. So if I look at the random number table below and I do this, here's how that thought process happens. So I look at this first one here, and that's the 2-digit number. It's a 73, so that's a fail, okay? And then a 90 is a fail. And then I get because see, now at this point, when I start looking at this second test, I start looking at, is it now higher than, or is it in the first 72, okay? And so the 90 was not, but 39 was, Okay, so then that was now finally passing. So it took 3 driver's tests to pass on that one. So let's take a little look at the next one. The first one out of the chute was a 30. So that tells me that the first driver test, was within 1 to 34. So that was that was an 80. Sorry. So that wasn't 1 to 34, so that was fail. But then the second one has to follow the guidelines of 1 to 72, and it was. So it was passing. Okay. And then the next one, 52. So remember, when we're looking at that first test, we have to look at 1 to 34 as our success rate, and that was not it. The next one, 13, success. 68, failure. 99, failure. 25. Now, let's see. This is interesting. Well, anyway, so hopefully by then you can see how that works. I guess I did 10 trials here. That gave a 2.1. I can't remember. Oh, if I had done 5 trials, that yielded 2.6. So anyway, according to my simulation, I expect to take about 2.6 road tests on average to pass. Now, FYI, let's just make sure we got our trial consists of taking the road test until a passing one is a passing score. The repeats are okay, because the road tests are independent of each other. Now, we are making sure that we are paying attention to these varying pass rates based on if it was the first test or the subsequent test. The response is that number of road tests I had to take until I got one. So there's why our response were number values. And then my statistic, I averaged those. Okay, so that was that last one on the assignment 2.